Greetings to all you exquisitely inquisitive ladies, gentlemen, and scholars, and welcome to Philosophia Naturalis with J. Allen. In this episode, we shall be observing a function and seeing exactly where in this function is the maximum and the minimum values of that particular function. And we will be doing this by finding where the critical values of this function is and using the closed interval of the function. Right, so here is our function, and the first thing we do to start off is find the derivative of this function. And here is our derivative. F prime of x equals 54 minus 6x squared. And the next thing we need to do is set this derivative equal to 0. And here we have the algebra all worked out for us. So after setting it equal to 0, we get negative 6x squared equals negative 54. And from here, we have x squared equals negative 54 over negative 6. And now we have x squared equals 9. And from here, we have x equals plus or minus radical 9. And don't forget your plus or minus. That's very important. Next, we have x equals plus or minus 3. And so this is what is called our critical values. Next, what we need to do is find out if our critical values are within our interval. And we can see here that yes, positive 3 is within our intervals, but negative 3 is outside of the interval. We can see that negative 3 is less than 0, so we won't be able to use that point. So we'll just simply cross it out, and all we're left with is positive 3. Our next step is to plug all of these values, the positive 3, the 0, and the 4, all of them into the original function. We will do this separately, of course, not all together. That would be crazy. So here we go. Here we are. So when we plug the 3 into the original function, what we get is f of 3 equals 113. So one of the points on the graph will be (3) and 113. And so the next thing we need to do is plug the 0 into the original function, and that obviously the 0 will eradicate everything but the 5, so all we're left with is the 5. Next we will plug the 4 in. And so, as can be seen here, f of 3 equals 113 is the maximum value. It is larger than f of 0 equals 5, and as well, it is larger than f of 4 equals 93. So the point 3 and 113 is the maximum value. And the minimum value would be f of 0 equals 5, because it's lower than f of 4 equals 93. And so that's about it. We've found the maximum value and we've found the minimum value on the graph. So we have some idea of what the actual graph looks like simply from looking at the original function. And so, to give you a brief conspectus of everything that's been done here thus far, we've taken the derivative of the original function, we've set that derivative to 0, and we've solved for the function of that derivative, and that gave us 2 critical points, plus and minus 3. We found that the negative 3 was not in the interval, so we threw that one out. And the positive 3 was, so we kept it. And we plugged that positive 3 into the original function. And we also plugged the endpoints of the interval into the original function to find which is our maximum and minimum points on the graph. And so we found that f of 0 equals 5 is the minimum, and f of 3 equals 113 is the maximum. And so that's about it, really. I do hope that this was enjoyable to you as it was informative. And if you did enjoy this, please give it a like and subscribe, and have a great day.